Hello, welcome back. In the preceding chapter, we introduced SQL basics. You learned how to perform simple tasks using SQL language to create a table, to drop a table, to insert tuples, modify tuples, and delete table contents. And you also learned how to use queries, simple queries. This chapter, we will introduce advanced SQL features. You'll learn how to write queries using nested select statements, write queries using joins, to use table alias to join same tables, to use the in, all, any, exists, and unique operators for conditions involving sets, to understand the various join operations: natural join, inner join, left outer join, right outer join, and a full outer join, to use the union, all, intersect, and minus set operators, to create and use views to understand Oracle row ID and row num columns, and to create and use indices and clusters, to create and use database links for distributed queries, to create and use synonyms for database objects, to create and use sequences. All right, so let's first, and we're going to look at the nested queries. So you can write a query inside the query. So here's an example. Find the faculty with the highest salary. Now you can do a lot of things. Just use the SQL statements. Select statements, this is very powerful. Now, how do you do this? Well, and you may attempt to solve this query using the following statement. Here, select last name concatenated with comma with first name as name and salary. And here from faculty, you'll say, hey, salary is max salary. Now, this is not going to work because the aggregate function max cannot be in the where clause. To fix it, you can use a nested to query like this here. Same thing here, select from and where salary, you're going to select max salary from faculty. So this is the result here. Another example, find the department with the largest total salary. So you can write the query here, select, and here's the department, and you're going to group on the department, and this is the sum. And now having this sum having, so when you have having, you can use the aggregate function sum. So you're going to select the max sum from the faculty group by department ID. So then you're going to get to this, the department with the highest salary, total salary. So this is using select nested inside the select statement. All right, so let's look at joining tables. How you join those two tables, get the information across tables. So here, we're going to list the courses taken by student Jacob Smith. So this information is enrollment. So here, student takes courses. And we're going to list the courses and taken by student Jacob Smith. So you're going to perform a join. So there's two tables. They're common reference. The foreign key is the student, this is the social security number. So if they match here And so this is, and so look here, the last name, the student, the name is Jacob Smith here, and taking this course, we're going to find the course ID, and then we're going to get the course information. So when you write this, you're going to get this last name, first name here, and concatenate here with the comma as name, and here's the course ID. So the student dot social security number is equal to enrollment dot social security number, and the last name is Smith, and the first name is Jacob. So here, from here, you get the information for the student Jacob Smith, and all the courses, the student text. So this is, and get the distinct ones. Student and enrollment have the same attribute, social security number. To distinguish them in a query, you have to use student dot SSN and enrollment dot SSN. Otherwise, and it's ambiguous, it cannot be processed. When joining two tables without the well clause, the result is a Cartesian product. So for example, all the pairs of two rows from each table are selected. So here, and in the SQL 2, we have this natural join you can use, and join operator, and that can be used in the from clause to specify a join of two tables. This is the syntax: A natural join B, and so there's so join joins A and B on their common attributes. The syntax: A join B on condition, and joins A and B with specified condition. So you can write this here from. So from here, you can write student natural join enrollment. So this is the same as this writing this student.ssn equal to enrollment.ssn. So here is the one. All right, you can also use join, student join enrollment on student dot social security number and equal to enrollment dot social security number. So this is using the join. All right, so let's see. Sometimes we use we have to use the tuple aliases. In the preceding query, you distinguish attributes by prefixing the table name before the attributes using the dot notation, student dot SSN and enrollment dot SSN. Occasionally, you need to join rows from the same table as in the following query. So here's the query, and find all pairs of students with the same phone number. So here's the same phone number. List the students and their common phone numbers. I'm going to list the students with the common phone numbers. So you're going to have to join those two tables. This is the same phone numbers. You need to join the student with student here. So how do we do this? We can use this from student. We use this alias for the table here, S1, and student, and here S2. So they actually refer to different tuples here. S1 phone is equal to S2's phone, and S1 social security number is less than S2 social security number, just to get things they're different. So if you don't have this condition, the S1.SSN and less than this, and you're going to get the same name and appearing here. So we're going to join these two tables, and this is actually the same table, and to find the common ones, it's the phone number. So that is here, and you're going to see. And so here, student John Stevenson, and this is the John Smith, and they have the Jean Smith, and here, and they have the same phone number. Yeah. All right, so this is when you join two tables and you use the alias. And now let's look at the conditions involving sets. SQL provides operators in, all, any, exists, and unique that checks value in a set to produce a Boolean result. So you can use this in your where clause. So here's the expression here, and E in S, and checks whether value E is in the set S. And expression here, E, the operator, and all S, and it uses the comparison operator. So this is the comparison operator to compare E with every value in S. This is all. The result is true if only if every comparison value is true. So this is any, is you just need to compare with one of this is true, then the whole thing is true. Exists returns true if and only if S is not empty. So exists this. And here unique S returns true if and only S has no duplicate tuples. So that's unique. All right, look, all Boolean expressions can be negated by putting the not keyword in front of the expression. And also please note that to use E and with the operator S, provided that S has a single value. So you can use this E, and if S is a query that results in more than one value, and there will be an error here. So this, if you use and see the subtle, and so you have princess, and here it doesn't have the princess. All right, so we are going to look at this. Find all faculty in the computer science and mathematics departments, the query result. So we're going to find all the faculty. So here we're going to get all the faculty. So where's the department in? And so we're going to get the department ID. So from the faculty. So here's from the faculty and the department ID. So where do you get this this computer science and the mathematics? So here, this is the department ID. So faculty is here either from the ID of computer science or ID of mathematics. So this is the ID. And this is using in and in. So the in operator. Many queries involving the in operators are nested queries. They can often be rewritten using joins. So for example, the previous one, you can join the faculty.department ID is equal to a department ID. So you're gonna get the information from faculty table and department table, and they're joined together. So this is the name is computer science and name is mathematics. There are many ways to write queries. All solutions are acceptable and there is no difference in performance. SQL is a non-procedural language. Each query is translated to procedures and optimized by DBMS. So you don't have to worry and how this is optimized behind the scene. The advantage of using joins is that you can display attributes from both tables. So here is from faculty and department, you can display from both tables. For example, and you can have this department name displayed. So here's department name displayed, and for this faculty in the math and CS. So let's look at this example here. Find all faculty whose salary is greater than the salary of all faculty in the math department. So greater than the faculty of the salary of all the faculty in the math department. So you can write this query here and select first name and concatenate with this space and last name as faculty and from faculty. So you get a salary is greater than all from the math department. You're going to select all this type of faculty. And this query, you can rewrite it and using this. So here is from the faculty. So the salary is greater than, you selected the max salary and from the math department. So that's also fine. All right, so let's write another example here. Find all students who take at least one course taught by Alex Badet. List the student names and the course titles. The query result is shown here. So this is, you're going to select the first name, concatenate with a space and last name. And here's a student and a course title. From student enrollment course, you're going to find all students take at least one course taught by this. So you're going to join this course with enrollment and the student and with the enrollment. So the enrollment.id is any, you're going to select any of this taught by Alex Badet. So this using any. So here, you're going to see this. We have this any s. So, so this any here s is the same as e in s. So the previous query can be written as, so you can use in. So this should be a parenthesis here. So in s. So this is in e. In S. So here is this. So you can write it here using this. ID is in any class and taught by Alex Badet. So another example, find all faculty who currently don't teach any course. The query. So here, this is the query you can write. Find this faculty and not exists. It's any of the class here. The course is taught. So this is taught by, it's not there. So this is the other faculty from the faculty table. They don't teach any class. So please note that we're using this F here because we need to reference it. This is the faculty Social Security number equals this taught by Social Security number. Now, we use a lot of examples to demonstrate this. So I think what you need to do is you're going to look at this query, you read it once, and then you come back to practice, write your own query and test it out and compare it with this and you're going to get some inspirations and do some practice. All right. I think I'm going to stop here and prepare for the next video. Thank you for watching and see you on the next video.